Imagine a scenario so extreme that it pushes the boundaries of what we believe is possible in the animal kingdom. A situation where a lion or a tiger is forced to jump from a plane and experience freefall. In this thought experiment, we explore not only whether these magnificent big cats could survive such a harrowing plunge, but also what inherent physical and biological factors might contribute to their chances of survival. While no modern zoo or wildlife reserve would ever subject a lion or tiger to such an ordeal, considering the physics and physiology involved provides an intriguing glimpse into the resilience of nature and the limits of animal endurance. At the heart of this extreme scenario lies the question of survival during freefall and the impact of high-altitude conditions on these animals. Both lions and tigers have evolved to thrive on the ground, relying on strength, agility, and stealth to navigate their environments. Their powerful limbs and robust bodies have been honed by millions of years of evolution for activities such as sprinting, climbing, and pouncing on prey. However, falling from a plane presents an entirely different set of challenges that neither species is naturally adapted to face. In freefall, an animal is subjected to intense gravitational forces, rapid changes in air pressure, and a high-speed impact that can easily exceed the limits of biological tolerance. When considering which of the two big cats might have a higher chance of survival, several factors come into play. The first is body structure and weight distribution. Tigers are generally larger and heavier than lions, with a more muscular build that emphasizes power and strength. Their bodies are built to absorb and deliver tremendous force in the context of hunting. But this same robust musculature could also work against them in a high-velocity descent. A heavier body creates more kinetic energy during freefall, which, if not mitigated by some form of aerodynamic resistance, could lead to catastrophic injuries upon impact. Lions, while still powerful, tend to have a slightly more compact build and may benefit from a marginally better weight distribution that could theoretically allow for a bit more control in the chaotic environment of freefall. Another important consideration is the adaptability of the animal's physiology to sudden, extreme stress. Neither lions nor tigers have evolved mechanisms to survive impacts from great heights. Unlike some birds or bats that possess a degree of shock absorption in their skeletal structures or specialized respiratory systems for high altitudes, big cats have not been subjected to the evolutionary pressures that would select for such traits. Their cardiovascular and respiratory systems are optimized for ground-level pursuits, chasing prey across the savanna or stalking silently through the jungle, but are not built to handle the rapid decompression and intense forces encountered during a fall from an airplane. Yet, when we look at instances in the animal kingdom where creatures have survived falls from significant heights, we often see that a combination of body flexibility, the ability to spread out the impact force, and sheer luck plays a vital role. In our hypothetical scenario, one might imagine that if either a lion or a tiger were forced to jump from a plane, their survival could depend on the way they instinctively try to position their bodies during freefall. While neither species has evolved parachuting abilities, it is possible that an animal's natural reflexes could lead it to adopt a spread eagle position, somewhat similar to the way a cat twists its body to land on its feet during a fall. This instinctive maneuver, observed in domestic cats, is a survival trait that helps reduce the impact force by increasing air resistance and aligning the body to minimize injury upon landing. However, both lions and tigers are significantly heavier than domestic cats, and their larger mass would mean that even with an optimal body position, the deceleration forces at impact could be extreme. The effectiveness of such a maneuver would be greatly diminished by the sheer scale of the jump. A jump from an airplane cruising at high altitudes involves speeds and impacts that are far beyond what a terrestrial animal is designed to handle. Considering historical accounts of animals surviving falls from great heights, we find that there are rare and isolated instances in which creatures have miraculously survived due to a combination of factors such as the presence of soft landing surfaces, aerodynamic body posturing, or sheer chance. For example, there have been reports of livestock and even pets surviving falls from significant heights. But these instances often involved fortuitous circumstances like falling onto a snowbank, a body of water, or a patch of dense vegetation that helped absorb the impact. In the case of a lion or tiger, the likelihood of a similarly soft landing is minimal. Most open environments, whether a savanna or a jungle, provide little in the way of cushioning that could mitigate the forces of impact. Without the benefit of an engineered parachute or a naturally soft landing zone, the probability of surviving such a fall would be extremely low. The effects of high altitude itself pose another set of challenges. As the animal falls, it would be exposed to extremely cold temperatures and reduced oxygen levels. While big cats are capable of handling variations in temperature, the sudden and severe change from the controlled environment of a plane to the frigid, oxygen-poor conditions at high altitude would add an extra layer of physiological stress. The rapid exposure to cold can lead to hypothermia, while the low oxygen environment could cause disorientation and affect the animal's ability to react appropriately during the fall. These environmental factors, combined with the physical trauma of high-speed impact, create a scenario in which survival would be a matter of extreme chance rather than any inherent adaptability of the species. Despite the grim odds, one can imagine a cinematic narrative that explores this hypothetical situation with dramatic flair. Picture a scenario where, against all expectations, a lion or tiger is accidentally ejected from a malfunctioning cargo plane. The fall, captured in slow motion, reveals the animal's desperate flailing and instinctive attempts to control its body as it plummets towards the earth. The tension builds as viewers are left wondering whether the creature's natural reflexes might somehow mitigate the impending disaster. As the animal nears the ground, the scene shifts to a surreal, almost dreamlike sequence where time seems to slow, highlighting the intricate details of fur rippling in the wind and muscles tensing in anticipation of impact. The narrative voiceover interweaves scientific commentary about the forces at play, the limits of animal physiology, and the rare instances in nature where survival defied the odds. In one version of this extreme scenario, the animal might somehow manage to land in a body of water or a dense thicket that softens the blow, triggering a miraculous, if temporary, reprieve from certain death. The camera would then capture the animal's slow, agonizing recovery, with every breath a testament to the resilience of life. Experts in animal behavior and physiology might weigh in on the scene, discussing the theoretical possibilities and the sheer improbability of survival in such a case. They would point out that while there have been isolated cases of animals surviving falls from remarkable heights, these are exceptions that rely on a confluence of very favorable factors that would be nearly impossible to replicate in the case of a large, heavy predator like a lion or tiger. The narrative could then shift to a broader reflection on what such a scenario teaches us about the limits of natural evolution and the extraordinary circumstances under which life can persist. It is a story that not only challenges our understanding of animal physiology but also serves as a metaphor for the resilience and unpredictability of nature. The idea that a creature built for the rigors of the wild might face a catastrophic challenge from which it could emerge unscathed is both terrifying and awe-inspiring. It forces us to consider the fragility of life and the myriad factors that contribute to survival, factors that extend far beyond mere physical strength. In the end, while the notion of a lion or tiger surviving a jump from an airplane remains firmly in the realm of wild hypotheticals, the exploration of this extreme scenario offers valuable insights into the limits of animal endurance and the unpredictable interplay of physics and biology. The freefall would subject the animal to forces that are simply beyond the scope of what its body has evolved to endure. The immense kinetic energy generated by the fall, the sudden exposure to high-altitude conditions, and the absence of any natural shock absorbers make it a near impossible challenge for even the hardiest of creatures. Ultimately, the thought experiment serves as a reminder of the inherent boundaries imposed by nature. While we can marvel at the raw power and agility of these magnificent predators in their natural habitats, it is important to acknowledge that their evolutionary adaptations have been finely tuned to the conditions they normally encounter. The freefall from a plane, with its extreme forces and hostile environmental conditions, represents a scenario so far removed from the natural order that survival would be a miraculous exception rather than a predictable outcome. In this dramatic exploration of extreme survival, we are left with a profound appreciation for the evolutionary balance that governs the animal kingdom. The lion and the tiger, each in their own right, are marvels of nature, creatures that have evolved to meet the demands of their environments with astonishing precision. Yet, when confronted with the unnatural and catastrophic challenge of freefall from a high altitude, even these apex predators would find themselves overwhelmed by forces beyond their control. The narrative, rich with scientific inquiry and dramatic storytelling, underscores the reality that survival is often a delicate interplay of chance, environment, and physiological resilience, factors that, when pushed to their limits, can render even the mightiest creatures vulnerable. Thus, while the idea of a lion or tiger parachuting to safety from a plane remains a fantastical notion best reserved for the realm of science fiction and extreme thought experiments, it serves as a powerful illustration of the delicate balance between nature's design and the brutal laws of physics. In contemplating such an extraordinary scenario, we are reminded that the survival of any living creature is never guaranteed, and that the forces of nature are as unpredictable as they are unyielding.